Welcome back, math people. Today we're going to talk about Chapter 10, Lesson 7, and we're going to focus on volume of prisms and cylinders. Shifting gears a little bit, the last couple lessons we talked about surface area, and this whole chapter we've talked more or less about area. Now we're going to talk about volume. And volume is not how loud something is, but in the mathematical sense, it's going to be how much space is on the inside of a three-dimensional figure. Now, we've talked about surface area. That's how much space is on the outside of a figure. But now we're going to talk about all the stuff on the inside of a three-dimensional figure. So let's go ahead and just kind of clarify the difference between area and volume. For those of you guys who have been watching the videos and paying attention to me recently, you probably know by now that area is squarea. Now, what does that mean? Well, that means that whenever we talk about area, we should be talking about square units, whether it's meters squared or feet squared or inches squared, yards squared, any type of length squared, that refers to area. Area is squarea. Cool? Well, today we're going to talk about volume. And when we're talking about volume, we're going to say if area is squarea, then volubic is cubic. Now, that's not nearly as good or as catchy as area is squarea, but it works. And what this means is instead of having square units, we're going to be talking about cubed units. Like meters cubed would be an example of volume. Feet cubed would be an example of volume. Inches cubed would be an example of volume. So, we need to understand the difference. Now, why is volume cubic? That is a good question. So, volume is the amount of space on the inside of a three-dimensional figure. Take this picture of a rectangular prism, for instance. A rectangular prism actually has three dimensions. It has length, width, and height. These three dimensions, let's say that this length is in, let's say, meters, and this width is in meters, and this height is in meters. Because I have three different meter dimensions, the units would be meters cubed. Now, the volume is all the stuff on the inside. So think about the room that you're in right now. The room that you're in has volume. It not only has a floor that you can walk on, but it has a certain height that you can stand up and actually move around in the room. So any figure that has three dimensions, all right, that means that it has volume. Volume. Today we're going to talk about volume of two specific shapes. We're going to talk about the volume of prisms and cylinders. Now, the good news about this lesson is both of them actually have the same exact formula to find the volume. The volume is going to be the area of the base times the height. So for this prism right here, the area of the base would be all of the space on the bottom level, the bottom layer, the base right here. And all we're going to do is multiply it by the height. Okay? For a cylinder, the same formula is true. The area of the base times the height. Now, we want to be careful because different shapes have different areas. This is a really weird area that we would have to figure out. This is the area of a circle, which is pi r squared. So, depending on the shape, it might change. All right. So let's go ahead and just be a little bit more specific. If we have a rectangular base, the area of the rectangle is base times height, and this just applies to the base alone, times the height of the shape. If we have a triangular base, it's going to be base times height divided by 2, and this is just for the base, the triangle, times the height of the shape. And if we have a cylinder, then it's going to be pi times r squared times the height of the shape. And we can use these formulas in order to find our different volumes. Now, suppose we have a triangular prism just like the one illustrated right here. Which side is the height? Good question, Mr. Lopez. Thank you, Mr. Lopez. I appreciate you, Mr. Lopez. Stop talking to yourself, Mr. Lopez. All right, how do we know which side is the height? Well, I'm going to go ahead and say that this guy right here is the height. Going from here to here, this is the height. Now, you might be saying, well, wouldn't this be the height going across here? Because the height should go from the floor to the ceiling. So isn't this only as tall as from the bottom of the triangle to the tippy top? Well, kinda, but not really. All right. So if we want to figure out the height, let me ask you this. How tall are you? Don't answer out loud. How tall are you? Well, if we were going to measure your height, we would measure from the ceiling to the floor. Now you can tell I obviously took this picture off of Google. Don't tell Google. All right. Now, looking at this picture, you can see that this boy has a specific height. Now you might be 5 feet, 5'6", 5'9", 5 foot whatever. Some of you guys might be 4 feet. I don't know. All right. But your height is going to be measured from ceiling to floor. Now let me ask you this. If you laid down, did you get shorter? Well, no. Because if you were 5'4" standing up, you are still 5 feet 4 inches laying down. It doesn't matter if you're standing straight up and down or you're laying down. We're not going to measure like the width of your head and say, well, I'm 9 inches tall. No, it doesn't work that way. Your height is going to be your height no matter whether you're standing up or laying down. Now you can look at this triangular prism and you can say that this is just a triangular prism that is just laying down. And we can tell this is a triangular prism because you can think of the bases as the feet and the head. If this base is the foot and this base is the head, all right, the height is going to be this section. So it doesn't matter if they're standing straight up or down, or standing straight up and down, or laying down. All right, the height is the height. So the height for this boy would be from here to here. This would be the boy's height. It doesn't matter. And this would be the same exact height if he was standing straight up or down. Now you might have noticed that with rectangular prisms, which side is the base, which side is the height, that's all which side are the bases is all a matter of perspective. Like looking at this one, you could say that this section is one base and this section is another base. So the height could be here. But if you notice that it is equally true, and the way that they listed on this one, is that if you made this section the base and this section the other base, then the height goes from here to here. So you might be wondering, which one do I use? Well, the truth is, and this is special for rectangular prisms, all right, the volume for any rectangular prism is going to be length times width times height. It doesn't matter which one is the base or which one isn't. For rectangular prisms, you can use this shortcut and it'll work every single time. So if you notice that you have a rectangular prism, it'll be length times width times height. In this case, length times width times height. If I said that this had a length of 3 inches and this has a width of 4 inches and this has a height of 6 inches, the volume would be 3 times 4 times 6. 3 times 4 is 12. 12 times 6 is 72. And we would have 72 inches cubed. Because if area is squarea, volubic is cubic. Let's go ahead and do two examples of finding volumes together. Now, let's go ahead and find the volume of a prism. Find the volume of the triangular prism at the left. Now remember, the formula for volume is the area of the base times the height. In this case, we need to find two things: the area of the base, and we also need to find the height of the shape. If we have those two things, we're good to go. Now notice, our area of our base has to be using the triangle formula because we have a triangular base. In this case, the triangle formula is base times height divided by 2. And this is just for the area of the triangle. So it looks like this has a base of 6 and a height of 10. Realistically, it didn't matter which one was which, because we have to just kind of realize that this is commutative. 6 times 10, 10 times 6 is going to be the same thing, divided by 2. Can anything cross cancel? Yeah. 2 and 6 can become a 1 and a 3. So this becomes 30 centimeters squared. Now, what is the height of the shape? Well, the two bases are like the head and the feet. That means that the spine, or the height, or how tall this thing will measure, is going to be 21 centimeters. Therefore, the volume is going to be the area of the base is 30 centimeters squared times 21 would give us 630 centimeters cubed, because volumic is cubic. All right. Now, the important thing for this one is that you identified what shape is your base. Our shape was a triangle, so we use a triangle formula to find the area of the base. For our last example of the lesson, we're going to try to practice finding the volume of the cylinder. They ask us to round it to the nearest cubic foot. No problem. Remember, the formula is going to be the area of the base times the height. The base in this case is going to be a circle. So our area of our base is going to be, the area of a circle is pi times r times the height of the shape. Cool. In order to solve this one, we need to figure out what is the radius and what is the height of the shape. The radius is going to be 11 feet because it starts from the center and goes to the outside. This is 11 feet. And the height of the shape is 5 feet. So if we plug all of this stuff in, pi is the same thing as 3.14. The radius is 11. The radius is still 11. And the height of the shape is 5. If I take all of this information and plug it into a calculator, 3.14 times 11 times 5 equals 1,899.7 feet cubed. Now, they do ask us to round to the nearest cubic foot. So rounding to the whole number, this thing is going to round up because 7 is greater than 5, 5 or greater. Then we're going to go ahead and make this approximately 1,900 cubic feet, because volumic is cubic. All right. That concludes this lesson. Good luck. I hope it was very clear and very easy for you. If you have any questions, feel free to ask. All right. See ya.